All right. Today I just want to give a quick overview of the whole theory of plate tectonics and then some major plate movements and stuff like that. So basically the whole idea is that our Earth is divided into 12 plates. We are on the North American plate, which makes sense because we're in North America, and our plates are constantly moving around. So at these different boundaries or where plates meet, we have different things that form. So just as a quick thing is, it's really important to know how the plates move. Plates move because of convection currents. And if I could make anything that is extremely important, it's this. Convection currents drive our plates. They are the things that make our plate tectonics move. And they have to do with density. So I have the bottom here is hotter, right? The core is pretty hot. It's a couple thousand degrees. And as it gets hotter, this entire mantle right here is liquidish. It's a very, very soft liquid. And so as it gets hotter, it becomes less dense and rises. Then it gets to the top and it starts to cool down. And as it cools down, it goes slowly downwards. And as it goes downwards, it starts to pull our crust, our tectonic plates. And then it comes back down. And then it gets heated up. And it does the same thing over and over. It heats up and cools down in a circle. And it drives our plates. Think of it like a conveyor belt. And it's the thing that makes our plate tectonics move. This is the thing that Wegener needed to make his continental drift theory viable. He didn't have this, and so that's why it was originally rejected. But after we kind of discovered more about our Earth, this proved his theory. So plate tectonics, a very major thing to know, and I want all eighth graders to remember, is that convection currents are the things that make our plates move. So we have three different types of boundaries. So when plates are either divergent, convergent, or transform, it describes how they're moving. So a divergent plate boundary. Divergent plate boundaries means that the plates are moving away from each other. They are dividing. So as the middle right here, as the plates move away, we have that hot magma from below come up and it makes new crust. And it just keeps making the same process. When we have a divergent plate boundary, we have what's called a mid-ocean ridge. These are places where they're moving away, and that magma is filling the gap, and as a result, they're making new crust. Our next one is a convergent plate boundary. Convergent collide, meaning they're coming together. Convergent collide. So when these collide, there are three situations we could have. We could have continental crust colliding with continental. We could have continental and oceanic crust colliding. And then we can have oceanic and oceanic colliding. In each of these situations, they create a different structure. So the first one is continental-continental. When I have two land or two continental crusts colliding, I make mountains. As they collide, they both come up and they create mountains. One really big example is the Himalayan mountains. The Himalayan mountains are formed because the Indian plate is smashing into the Asian plate. And so as that comes up, those two crusts collide, they come together, and they start to form mountains. When we have continental and oceanic crust, we have something different. Oceanic crust is more dense, and we've talked about before that density has to do with how things float. So since that oceanic crust is more dense, it's going to go below, and the continental crust is going to go above. In that case, we have something that's going on here where we go down, this rock starts to melt, and as it melts, it becomes less dense and wants to rise up to the top. This is where we create volcanoes. So we have places in America, we have around Oregon and Washington, there's a very small continental and oceanic crust colliding. So therefore we get volcanoes forming. One example is Mount St. Helens. Mount St. Helens erupted about 30-40 years ago, and it's the last known eruption here in the U.S. Now if we have oceanic and oceanic colliding, we have two oceanic plates, they're both dense. So it goes by which one is older. The oldest one is more dense, and therefore it sinks. So when this happens, we have oceanic and oceanic. We don't necessarily create volcanoes, but instead we create volcanic islands. So these are things where they have erupted and they have slowly made islands out of all that volcanic eruption. And our last one we'll go over today is transform boundaries. At a transform boundaries, they are sliding past each other, and they're grinding and moving slowly past each other. So as a result, we get earthquakes that form. So California has a lot of earthquakes. They have a lot of plate movement and plate boundaries moving on. So one example is the San Andreas Fault, where those two plates are sliding past each other. And as they slide past each other, plates, they kind of get caught up, and then when they release that pressure, they create a big wave we call an earthquake. So transform boundaries slide past each other, and then they create earthquakes. I hope this has been a quick, helpful lesson on the differences between the boundaries and what they create. I encourage you that if you are struggling or you're not sure which is which, to rewatch or to go over your notes that we did in class.